Welcome back to the channel, folks. If you're a first-time viewer, just welcome. Today we're going to be switching gears a little bit and going back to some analog mechanical things. Today we're going to be looking at the quick-release grinder nut that Lidl has released. The PSMW 1A1 came out on the Spanish market some weeks ago and is now coming to the wider European market. As you can see, comes in this little box and is obviously a new addition to sort of the grinder accessory market. So we'll just pop it out of the box. Here we have just a little set of instructions we probably won't need, and this nice sort of wax paper wrapper with the nut inside. You can pass that to the side, and as you can see, this is a fairly substantial piece of hardware, and obviously it has some kind of mechanism inside to facilitate undoing from the grinder spindle, and isn't just an oversized nut to, give you a nicer grip when you're trying to undo it. So if we compare this to the grinder nut that actually comes with the professional or the performance series grinder PWSAP 20, this one here, you actually get this quick release nut already in the box on the tool when you get the grinder, but this one here is obviously quite a different design and system compared to the one that's included with the grinder, and obviously much higher quality. So let's take a look at what it really means to have a quick release nut on your grinder. So here we have our grinder, we have our spindle, we have our cutting disc attached here, and then we have the counter nut on the top and our either normal nut or quick release nut here. So every time you start the grinder, there's a high acceleration that just tightens this nut up every time you run it. And of course, since the startup acceleration is much higher than when you turn it off, every time you run the grinder, this nut just gets tighter and tighter. So what we have here friction-wise that's holding it stuck to the grinder spindle, we have our friction between the disc and the surface of the nut pressing up against the disc, and we also have the increased tension on the threads of the nut where it's torqued down really tight, and we have high friction on the threads too. So if we want to design a quick release nut that you're able to undo by hand and not need a grinder wrench, well, you're going to have to either reduce the friction between the disc and the nut, or you're somehow going to have to reduce the friction on the threads. And that's exactly what these quick release nuts do. So the one that comes with the tool, you can see, is a very sort of simple, easy to manufacture design. We have these sort of different discs in here that have just been sort of crimped together by machine. And basically what the internal structure is on this one is that we have this sort of bottom green contact piece. This is this bottom metal area here. Then we have maybe some kind of roller bearing in between here, maybe not, and certainly some kind of conical washer or spring pushing down on this bottom plate and on top. So this area here is our threaded nut. So the idea of this quick release nut that's included with the tool is really just to reduce the friction between the disc and the nut, not doing anything to the friction on the threads, and it's just supposed to allow the surface that's on the disc to spin independently of the threaded nut piece. So this, if it has the roller bearing, or even if it's just sliding on the edges of this conical spring, this bottom contact piece is separate from the threaded nut and is able to turn independently. So when you're trying to undo that nut, you don't have to be fighting the friction on the disc itself, since that bottom part that's in contact with the disc can supposedly turn freely, and you're just fighting the resistance and the friction on the threads. So you can actually see that happening with this nut here. I've actually marked with sort of paint marker, I've marked where these discs are indexed, and now I can use this sort of rubber mat I can actually turn it, and you can see that the index marks have now sort of spun and turned. So this inner piece is able to move independently to this top piece. So this inner area that's in contact with the fiber disc can turn independently of the threaded nut, and that way you can reduce the friction, basically eliminate to a degree the friction between nut and disc, and you only have to fight the friction on the nut. And sort of this idea has existed for some time now. This is a patent drawing for, I guess, an improved Metabo quick release nut from some years back, and their setup is fairly similar. They have this contact area that's in contact with the disc. They have a roller bearing in here. They have a washer, and they have a spring that's pushing up against the threaded nut area. So supposedly, especially if you have a decent roller bearing in here, this metal piece that's in contact with the washer can spin independently of the threaded area. So when you're undoing this nut, you're just fighting against the spindle. You're not fighting the friction against the disc. And you can sort of see that in action here. So when it's unthreaded, there's no tension on the spring. The spring is extended. When you tighten it down against the disc, the spring is compressed. It pushes down this contact piece that's pushing against the spindle, and it keeps everything tight. When you go to undo this, you spin the threaded nut portion independently of the portion in contact with the disc, and you basically eliminate the friction between the nut and the disc, and you only have to fight the friction on these threads. So this is a fairly decent idea, and it works to some degree. So if we take our grinder here, let's pop on a fiber disc. Let's just take this quick release that's included with the tool, and let's tighten it down. Let's see how I can sort of hold the stop here and tighten this down. And you know, I can tighten this down a good degree, and then when I go to undo it, really need to press that stop fairly tightly. And you know, you can get this loose by sort of finger, but it's quite a struggle, I must say. If it gets any tighter than that, you're really going to need the wrench. So if we try it with this quick release nut, the new one, if I can just get it to thread on here, we'll actually see, so I can tighten that down fairly decently. And when I go to loosen it, it's super loose. It's much easier to release than the one that's included with the tool. So looking at the nut, we can sort of test it out with the different grinder attachment we have here. Your typical thin metal cutting disc, and this grinder disc which has this sort of internal depression in it. So no problem, this nut is compatible with practically all your grinders. It will work with the 115, 125 diameter size. It will work with the 230 bigger grinders too, no problem. The speed rating here, I guess max 15,000 RPM, but that should never really come into consideration. And as you can see, for mounting purposes, very simple to use. Definitely feels nice and heavy in the hand, certainly sturdy. You can easily tighten it down on your grinder discs, or if you want to use it with the thicker depressed discs, it has no problem being compatible with those either. It perfectly fits into that depression, and there's no issues of, let's say, fit or anything being a problem because of that sort of concave surface. They are perfectly compatible with both types of grinder discs. So that's pretty impressive. I mean, they're both quick release nuts, but this one is certainly much more comfortable to use. So let's see what's going on here. I've actually taken a look at this before, and you can see it's made up of a couple of independent pieces. We have this outer ring, we have this threaded portion on here, we have this gray surface area here that sort of spins, And if you take a kind of closer look onto the surface, you'll see there is a sort of spring clip in here, and there seems to be another spring clip below this gray area. So to my surprise, this is actually disassemblable. When you compare it to this one here, it seems to have been sort of crimped or kind of riveted through the middle. So this thing is sort of a one-use, or it's not able to be disassembled without cutting it apart and destroying it. So interestingly enough, this one can be taken apart, and that's exactly what I've done here. So this is my version that I've taken apart, and I'll explain the process, how you do that. So you're definitely going to need some kind of a pick. This is just a soldering tool that I had lying around with a nice sharp point. Anything of this type will do. And what you're going to have to do first is remove this spring ring that is attached around the center collar here. So just with a pick tool, you need to get into there and pop this off. And as you can see, let me see where the opening is, right? So you can see this spring ring is sort of cut in half, and you can release it from the center area here. Don't worry about those springs. I'll explain them in just a second. So when you've released that spring, you can pop off this center gray piece, and make note that it actually isn't free to spin on this piece. It is actually keyed and indexed by these square edges to be locked onto this threaded shaft. So keep that in mind as we continue our disassembly. So when we pop this gray piece off, the next thing we'll see is that there is this other spring clip that is hidden down in this groove. So again, with some kind of pointed tool, you'll have to get into these sort of openings here, these notches in the edge of the nut, and you will be able to release this spring clip around the perimeter, and it will just pop out. So once we've released the second spring clip, we should be able to go further in the disassembly. So then we have a rubber O-ring that just comes off. Then we have this thrust washer lying in here. Then we have this sort of contact plate that separates everything. And you'll notice that this roller bearing that's in the middle here, it really doesn't serve to facilitate rotation of this gray piece. It's actually, since it is locked in place to the center shaft, it really only serves to allow rotation of the elements underneath, as you will see in just a moment. So once we've gotten that out, we can release this center piece, if it is at all willing. There we go. We can release that. And then we get to the actual mechanism itself that we can start to see in here. And as you can sort of see here, if we can get this to focus, there we go. We have this one spring that is attached and pushing this little arm forward, and there are two other springs that are missing. These two little springs I have here, they are supposed to go and push these other two arms out in the same direction as this one. So the arms are being pushed counterclockwise. So we can remove that spring, pop it out, add it to our other three springs, and then we can actually pull out the core of the quick release nut that is actually sitting on these grooves that we have in this outer ring that you can undo when you're undoing it by fingers. It actually indexes into these three sort of pointing out fingers here. And this whole mechanism is able to spin on this inner shaft, which is quite interesting. So when we lift this metal plate here, we can reveal some roller bearings or just rollers that are sitting either on this bottom piece, or we have one here that is actually stuck on this top piece. We can just return that to its little home. We can remove this piece. Then we have this indexing ring that has these sort of bent notches that connects into the threaded nut just via these holes. And then from the center, we can pull up this roller carrier or little cage, and we've managed to carry over another roller, so we can just put that to the side and leave these rollers in place. And that just leaves us with this nut that has the threads in it. So this is a very interesting setup. So let's bring in this diagram. Let me move things around here a little bit, and then we can get a better view of what's going on. So what we have here is actually a fairly complex little mechanical machine going on to make this quick release nut work. So what's going on here is that we have this system of rollers. So we have this gray piece that's in contact with the cutting disc. Then we have this roller bearing. Then we have this rubber O-ring. Then we have this covering plate. And then we have this, what I'm calling a cam plate, which is actually this one here. And what happens with this cam plate is that it's riding on this roller carrier, which was this piece here with the little rollers in it, and it is either indexing together with these rollers and lying flat, as we can see here on the bottom, or when it is turned by these fingers, it sort of moves out of phase of the rollers, and it happens to sit further outside. So what this system basically does, as you saw this spring, when we put everything back together, and this will just take a moment of me to get this indexed correctly. So now I've gotten these rollers indexed to the nut and this outside locking piece, and you can see there's a little cutout on each side that allows this sort of roller carrier to move up and down a little bit. Nothing too interesting to see here. But once we attach this cam plate on top, we'll actually see where the movement comes from. So now that we've attached the cam plate to this roller carrier, we have these three fingers on the perimeter that allow it to turn, and these three fingers index into these little cutouts on our sort of grippy outer ring. They allow the outer ring to actually turn and move this plate. So what's going on here now? We have this situation where we have our roller carrier and our cam plate, and where this cam plate is able to turn against these rollers. So we have two situations. Either our unlock position, which is counterclockwise, where the rollers are nicely cocooned in their cutouts on both the roller carrier and the cam plate, or once we turn this, and you can hear a little click, you can hear that click. When it is in the counterclockwise position, the rollers stay aligned to the roller carrier, but the cam plate moves out of phase, and instead of the rollers lying in their cutouts, they're actually lying on the surface. And this actually moves this plate upwards by a little bit, about the diameter of these roller pins. The roller pins are about 2 millimeters. These cutouts here are only about 0.4 millimeters. So going from this setup to this setup, we actually only have an increase in height of just this fraction of a millimeter that this plate is actually moving up and down. And when you consider that previously we actually had these springs between this little notch here and our finger, that were pushing it in the counterclockwise direction, these springs were actually holding this plate constantly in the extended state. So what this basically means, when you have this quick release nut and it is either idle or it's being tightened, is that you have these rollers in this extended plate, which moves the whole internal mechanism up, and it means that this gray contact area is just a little bit further extended than it usually is. But when you go to undo this quick release nut, you have to fight against the spring tension, and you manage to return these rollers back into the collapse position, and you move the gray surface area that's in contact down just that fraction of a millimeter, 0.4 millimeters to be precise. So what's happening when you have a grinder disc here and you go to add the quick release nut, it is in the extended position and it nicely tightens down against the disc. When you go to undo it and you turn it counterclockwise, you compress those springs, and for an instant you actually take away 0.4 millimeters of thickness on this gray carrier. So what this pretty much does is it takes away not only the friction between the nut and the disc here, since this plate that is usually, in contact here, this plate sort of collapses down like this. So you basically eliminate all this friction against the disc and the nut in one instant. And also, since the nut now is not compressing against the disc anymore, it's sort of moved out a little bit, all that tension that was built up on the threads, it immediately collapses, and you pretty much just have the nut riding, on the threads very loosey-goosey, where you don't have to fight any tension in the threads. You can just undo it without any resistance whatsoever. So the ingenious design of this new quick release nut reduces and eliminates in the instant of releasing this nut. It deletes both the friction against the disc by retracting the contact plate, and in doing so it also releases any tension between the spindle and the threads and allows you to undo this nut without any resistance whatsoever. It basically feels like just spinning the nut on these threads when it's not being compressed or in tension. So really, I mean, this system and this tiny mechanism inside here is very much ingenious, and it is actually a much better design when you compare it to, this older or original quick release nut, where it is actually much, much easier to release than this one here. So I hope you enjoyed this little demonstration of really the intricate mechanical goings-on in something as simple as, this grinder nut. So I hope you enjoyed this video. There will be certainly more to come. I've been taking a look at the sort of sleep mode hack. I believe I have some improvements on that front. As you might have seen, our channel is nearing almost 1,000 subscribers, which is a great milestone to get to. Thank you to all subscribers who have joined the channel. If you're still out there and not subscribed, please hit that subscribe button. It would really show your appreciation that you enjoy these videos and really help me out to break through the YouTube algorithm with those additional subscriptions. So I hope to see you next time. We certainly have some very interesting projects and tools coming up for review. So until then, take care and bye-bye.